So I am Dr. Lauren Jozwiak, and I am a planetary volcanologist. What that means is that I study how lava and magma interact on different planets in the solar system. At APL, I work on a bunch of different projects surrounding that, everything from the moon to Venus to the outer solar system. And that includes developing new missions and working on some existing missions. So planetary volcanology and volcanology in general is so fundamental to how we understand planets because we can't get to the mantle on any planet. But the mantle is really the bulk of where the material of the planet is. And volcanoes and volcanic deposits take the mantle and they put it out onto the surface. So if you want to learn really anything about how planets formed, how they cooled down with time, what kind of materials might have been incorporated into the planet, you really have to study the volcanic deposits. And so that's why I'm interested in missions that pursue that so they can help us understand how the solar system formed and the differences in the different planets. I would say I was always a little bit interested in STEM, but I didn't really solidify until high school. And so my freshman year of high school, I was watching a NOVA program with my dad about string theory called The Elegant Universe. And I was convinced that I wanted to be a theoretical physicist. And so all throughout high school, I pursued as much science as I could. Around that, I grew up near Chicago, so I actually had an internship at Fermilab, the particle accelerator. And I also did an internship at the Adler Planetarium in Chicago, which interestingly enough convinced me that I did not want to go into astronomy. Fortunately, I softened on that stance, but my freshman year of college, I realized that I was not as in love with physics as I thought I was, but I had the good fortune to see a poster in the hallway the day before second semester started for a class called the Solar System. Like, well, I've always been interested in space, even though the astronomy thing wasn't for me. Let's take the class and see what it is. And within about 3 classes, I switched my major over to planetary science because it was everything that I liked about physics, which was really for me figuring out how things worked and how things in the universe worked. And getting to do that in space was just sort of the absolute dream. And within that, I sort of found volcanology as this really interesting window. It's great because volcanoes happen on all of the planets. So you didn't have to pick one to focus on, which I really liked. Planetary science is one of those fields where you can have, and it almost requires a lot of backgrounds, a lot of different backgrounds to come together to work. There aren't many places that offer undergraduate planetary science degrees, and that's totally fine because physics, chemistry, biology, meteorology, all of geology as sort of its own base, all of these different disciplines come together into planetary science. Again, I had the good fortune to go to a school that did have a planetary science degree, but even at the time I was taking it, it was an outgrowth of an old astrophysics degree that they used to offer. So I actually even modified the coursework from that to focus more on what I was interested in. So it prepared me, but not to any detriment if I had majored in anything else. And a good many of my colleagues did not major in planetary science in undergraduate. It's that there's a real breadth of degrees that you can take that can prepare you to go into a graduate program in planetary science. So I think one of the things that surprised me the most was how many projects that we work on. I sort of had this picture in my mind that I'm coming out in bright and bushy tail and an expert on this very, very niche topic that I was going to dig down and study. But then when I got to APL, there were just so many projects constantly were floating around, and planetary science is a field where we tend to think sort of 10, 20 years down the line at all times, looking for future missions, future mission opportunities, future technologies. And you're just constantly being pulled into projects where you might have some background, you might have no background. But at any given time, I probably have 10 different projects that I'm working on, and only 3 or 4 of them are actual hard research that I trained in. The rest of them are theoretical or missions or instrument concepts. something that is pretty common to planetary scientists is that there's a little bit of a random walk element, that you don't always necessarily get to choose the opportunities that are present at the time that you're coming along. So when I was coming out of graduate school, there was a mission called Messenger, which had gone to Mercury, which I was involved in as a graduate student, and it was just wrapping up. But through that project, I got to know many of the scientists at APL because that was the institution that ran the mission. And they had a postdoc opportunity opening up for the department. They didn't have anyone who specialized in volcanology, and they asked me if I would like to take the position. And of course, any job is a good job, and a job at APL is a fantastic job. So I was very excited to take that. And through the postdoc, like I said, I immediately got involved in a number of different projects, and you just sort of, you stay and you get embedded in that. And so I like the variety that it gives me. I like getting to work on different mission opportunities. I think that's what's kept me in this position so far, because as a professor, your priorities are different. There's obviously still a heavy emphasis on research, but a lot of it is on getting funding for your students to do research as opposed to yourself doing research. And then of course, emphasis on teaching as well. So I haven't ruled it out yet. I have guest lectured at several different universities. I've discussed opportunities at different universities, but I think where I am in my career right now, I'm enjoying doing the research myself. I'll tell you about two, because one of them is very exciting, but is several years down the road, and the one of them is very exciting right now. The one that's several years down the road is a mission that was just selected to go to Venus. It's called VERITAS, and I'm a co-investigator, a science team member on the VERITAS mission, which is so exciting because we have not gone back to Venus as the US in about 30 years. In fact, the previous NASA mission to Venus, Magellan, launched 2 months before I was born. So it's been some time, and the VERITAS mission is going to be just a really awesome mission, and my own personal role in it is going to be using the radar data that we get back to look for evidence of new active volcanism. And then another project I'm working on right now is using radar, again, at the south pole of the moon to look for water ice deposits, because we know, or we think we know, there's water ice at the lunar poles, but radar is really sort of the best instrument to actually find it, because radar sees depth. Most of the other instruments just see the top. It would be like looking at frost on your blades of grass. Yes, there's water ice there, but is it actually useful? Radar can tell you about the upper meter of what's going on there. And I will say that we think we found something very interesting. So I'm currently writing up a paper for Nature that will talk about some of those results and whether or not we think we found some really key areas of water ice exploration. It really depends on sort of what season you're in. So for example, if you had asked me this question back in February, I was working on 2 mission concepts that were in competition, VERITAS and another mission, a mission to Io. And so at that point in time, any given day would be filled with meetings and telecons with the engineering teams as we talked about the last minute tweaks to the instrument design, or answering questions that had come in from the review panel, brushing up on presentations, and then finishing up and presenting to the panel. On a much more normal day, I like to divide my time by planet. I can't really switch my mind too quickly between the different ones. So I'll do little theme weeks for myself. So I'm in the middle of a moon week right now. So it will involve, if there are any telecons that I have. So I have a couple this week that are looking towards a future project. We're trying to develop a new mission idea from scratch. So it's doing some background research for that one, involving what kinds of techniques we're going to want to use on this mission, or what techniques we could use that we'll have to pick between. I've been working on some figures for that Nature Geoscience paper, and so that's actually really nice. I like making figures. It's a little bit zen. And then writing. Writing is a big part of science, whether it's writing to get funding, whether it's writing up papers, whether it's writing summaries of your research to give to your colleagues. There's always some amount of writing in any given day or week. So technical knowledge, I would say starting off with a strong foundation in math, It doesn't have to be super crazy advanced math, but definitely calculus, linear algebra, differential equations. And then from the sciences, really at least a background in each of physics, chemistry, and biology, and then significantly more emphasis in sort of in whatever you do. So for example, as a volcanologist, I have a larger emphasis on geology and geochemistry, as opposed to someone who would say work on an atmosphere, then they would have a much stronger atmospheric and fluid dynamics background, or a modeler would have a stronger emphasis on programming skills. So that's something nice about this field, is you can find people who complement each other. In terms of soft skills, absolutely writing and absolutely speaking and presenting. Both of those are so important to being a good scientist, because you need to be able to communicate your ideas clearly in writing to be able to get funding to do your science, and then also to tell people about the science you did. And same thing with speaking, that conferences are huge in our field. We probably have one every couple months, and you can find many more than that, at least one a month to communicate your work at. And the more clearly you can do that to people, the more you're going to be sought out for your expertise. Go for it. It's a super fun field, and there's a lot of space. Basically, any sort of niche problem that you're curious about in the field, you can hunker down and really dig into. Whether it's a process, like for me, volcanism, or a planet, if you're super interested in Mars, or super interested in Mercury, or super interested in Pluto, you can find something that will grab your attention and that will just lead you as sort of like a rabbit hole. Follow that excitement if it's something you're interested in. But in terms of actually getting out there and doing it, I would say keep yourself broad. Make sure you have that strong background in a bunch of different types of science, because you might not know exactly what you want to focus in. And then also be aggressive and persistent in seeking out internship opportunities, even just cold emailing. I got my first internship in undergrad because I cold emailed someone who referred me to someone else who happened to have funding for the summer. So I flew out to Colorado to meet someone I'd never met to work on Olympus Mons on Mars. So a little bit of persistence, even if you are shy, like I definitely was in undergrad, but being persistent and being curious are really important. For people who are interested in STEM, really hit on some things from my own experiences, to be curious and also be honest with yourself about what you're curious about. So I think a lot of times we have this thought that you're going off to college, you perhaps know what part of STEM you want to go into, and you're very sort of gung-ho on that, but keep your eyes open, keep your ears open. If something is interesting to you, don't be afraid to pursue it, because you might find something that's an even better fit for you. And then the other advice I would give is a little bit more niche, but it's for all of the shy people who, like me, didn't want to raise their hand in class, knew the answer, but were terrified of raising their hand. That can be a little bit difficult in fields like STEM, which rely on professors writing good letters of recommendation for anything from internships to graduate school. It's not really a field where you can sit in the back, ace all the tests, and then expect to move on. So my advice for those people who might be a little bit more reticent or might be a little bit more shy, the first one is very, very actionable. Sit in the first 3 rows, because that is where professors make eye contact. And if they see you and see that you're engaged, even if you don't raise your hand, they will take notice of that, and that will show up if you're asking for letters of recommendation down the line. The next one is go to office hours. If you can find a TA or find a professor who you really engage with, going to their office hours can be really great, not just for the career advice, but also for that personal connection and what they can help open doors with their own powers. So my third piece of advice is, if you are interested and if you have questions, email the professor. So if you just email them and let them know that you're interested and know that you're thinking about these things, that can be just as impactful as having gone to office hours or having raised your hand in every single class.